Hello? Okay, I can hear myself quite well. I guess we'll start with that. Okay, so yes, hi, my name is Andrei Warkentin, and today I'll be talking to you about the BRS spec. So we will cover the overall context for the spec, what the whole thing is about, what markets the spec is targeting, the goals behind the spec effort, the kind of divisions of how the spec has been divided up in different sections, the progress on the spec. We'll talk about compliance testing, maybe reference platform, and the next steps with the spec. So the context here is, this is a pretty familiar diagram. You've seen something like this this morning on Mark Hamilton's presentation. So, we have the ISO profile effort, which is aiming to define this common base, of a usable ISO, for, let's say, high-end use cases. We have a server SOC spec, or in general, hardware specs, but in this particular case, I'm referring to a server SOC. So that talks about the kinds of aspects that you would, how do you build a server system? What goes, how do the hearts work? What's around the hearts, the different IP blocks, and all that. We have the PRS, the Platform Runtime Services TG, and this includes the M-mode SBI firmware. This includes the ACPI bindings, the E5 bindings, all kinds of firmware aspects, but these are just different specs and different blocks that could comprise this firmware. We have security specs. These are still, to my best knowledge, ongoing, but this would cover the kind of the security platform. What's missing from this is, well, how does an operating system boot on such a system? How is the system hardware described to the operating system? And that's the context for the specification. So this effort was previously known as the OSA SE. It's a bit of a mouthful, so after much deliberation, we have renamed this to the Boot and Runtime Service Specification. So the Boot and Runtime Service Specification talks about OS observable behavior relating to booting the operating system, describing the system, and the target audience are operating system vendors, right? Such that you can have a single distribution image of an operating system that can install on supported systems that implement the spec. So this is a kind of a different world than maybe what you're used to in the embedded world, where effectively you're saying, here's my special software, it's running on my special hardware, and I'm not running an off-the-shelf operating system. Okay, so what markets are we targeting? And there's this specification targets two different kinds of worlds. And the most interesting one, which maybe prompts this spec to exist, is what I like to call the horizontally integrated systems, right? So these are PC-like systems, PCs, servers, and laptops. You're talking about multiple vendors, building capable CPUs, then other vendors building motherboards around those, yet other vendors packaging these in systems, and then yet other vendors writing operating systems, and yet third, fifth, sixth vendors providing applications, right? So everybody collaborates, and you're talking about interchangeable parts, right? Maybe today I like a Ventana CPU, tomorrow I like a Revos CPU, today I boot NetBSD, tomorrow I want to boot Linux. All right. So again, single binary image compatibility. Now in this kind of world, you look at x86, you look at AIR64, you boot UEFI way, you describe the system hardware using ACPI, and you describe the kind of field replaceable units or the mechanical organization system with SMBus. There is another segment, which I like to call virtually integrated systems. These could be some client-based systems, mobile devices, Android Chromebooks. This could be embedded. This could even be cloud hardware in the sense that a cloud vendor may wish to simplify their own provisioning, like how they boot on the hardware. Of course, you may have more variety. Some of the embedded systems may be 32-bit. Of course, you're actually booting your own OS, most likely, or a customization of an upstream OS. You may prefer to use device tree, right? So these are the two markets that this spec covers today. This parallels, of course, to a degree, the efforts that have occurred in, let's say, ARM System Ready. Okay, so what are the goals of the spec? We want to target the horizontally integrated segment This is the one where you get the really cool stuff, the PCs, the desktops, the servers, okay. You also want to cover embedded or embedded style system. That does not mean low performance, but in the way how you build and provision these systems. Who is the target audience? The target audience are OS vendors, right? Especially on the horizontally integrated side. What does interoperability mean? I've kind of covered that a little bit. I'm able to take an image of Debian or Ubuntu, and I'm able to boot it on this new system that just came out enough to install. Now that may prompt, they may be missing drivers, but at least I'm booting far enough to know that you don't have a supported NIC. Okay, now we want to do this based on accepted industry norms and practices. I mean, maybe this sounds like it's common sense, but we don't want to reinvent the wheel. That also reduces the barrier to entry, kind of makes things not weird. Also, you want the spec to be useful today. So let's say you had a spec that said, well, in 10 years, when you'll have acceptable systems that meet some many requirements, this will be a useful spec. Well, what about today? Well, like, what would be the incentive for many of the RISC-V partners to continue working in a spec which they can't monetize today? And how will they know how to evolve it if they can't find out what's wrong with the spec today? Okay, good. Now, the specification, of course, builds on industry standards and other specifications like UEFI or ACPI, but what if we find something missing, right? So the goal is, the job is not to have the largest document on planet Earth, right? As we find gaps, yes, we may bring content into our spec, but the idea is that stuff gets upstreamed out. We work with the relevant spec bodies and kind of move as much of our content out and out into the relevant bodies. Okay, so the spec, it follows a very kind of specific style. From prior experience, what some of us have found is some specs like to duplicate things in other specs, maybe to call out attention, but it's confusing because then you're kind of losing where the boundary is. Like, is this a requirement made in this spec, or was that in UEFI? Like, why you're calling it out? Okay, so we're not going to duplicate anything that's actually referenced in the spec, but you might say, Andrei, you can't expect me to read a 1,200-page ACPI specification and know exactly everything I need to do. So the BRS spec also has a guidance section, so non-normative, but it provides, some human language around, like, well, you could do X, you could do Y, please read this section in that spec, it gives you helpful pointers for how to do stuff. All right. Okay, so BRS profiles, we have two flavors of these. So again, one we're calling bespoke, right? That's effectively the EBBR style, for those who are familiar with that term. It's the vertically integrated, is the embedded, but not necessarily low performance. This is a subset of UEFI requirements, and you're able to use device tree, that's what you want, or you can use ACPI. And then there's the interoperable flavor, and this, of course, targets server class systems, or similar, where you are now having an expected kind of conforming UEFI implementation, you're using ACPI and all that. Okay. Now, yeah, this spec does stick to 64 bits. We're not focusing on 32-bit. There are some commonalities, obviously. So remember how I said I want the spec to be useful today? That's why we're targeting RV820. Some of you may say, well, that's a bit old. Sure. I would expect the spec will be revved up, with some cadence, and of course you may see that these base requirements will grow. But today the RV820 allows you to make any existing board compliant. Okay, I see only two flavors here, and for those of you that are familiar with the ARM System Ready ecosystem, I'd say, well, where's your LBBR equivalent, right? Do you have a cloud-specific profile? What are those CSPs? Like, we can certainly have one. It's just not on the charter right now. There have been some interest, but again, in the interest of actually ratifying something, soon we're not looking at that right now. Okay, so where are we? Most of the document is complete, and I did not give you a link. That probably wasn't useful, but you can just look at it. It's the RISC-V, non-ISA. Most of the document is complete, and most of the content is there. Now, it needs obviously cleanup and review. This is one of the not so great aspects about the BRS group. There aren't that many people in it, and so there has been work on the UEFI spec to clean that up. You know, like I mentioned, because it's a spec for OS vendors, we really ought to be concerned ourselves with the things observable, right, from an S mode system, right? So you shouldn't probably start talking about M mode behavior unless it's directly observable. So we've been cleaning up the UEFI spec. We've actually cleaned up the ACPI spec too. So we have support for non-AIA systems. So if that's what was stopping you, you can use ACPI with PLIC now, you know. Added RISC-V support in some of the other specs like the SPCR, which is the way to expose a serial, no, not exciting, but serial port. You gotta figure out how to expose a serial port. Okay, so there are some aspects which are still missing and kind of due to dependencies. Obviously the RAS work is ongoing. There is an IOMMU spec, right? Mark mentioned this morning. There's an ACPI binding for that, but these things, it's still unclear. They're probably not gonna go into the first version of the spec. We have been working on an early version of a BRS test suite, more on that, and the reference implementation. So maybe kind of to dive deeper into the ACPI parts. Again, it's obviously 64-bit. We are strengthening the requirements, you know, so it's 64-bit clean. You know, we are supporting AIA and PLIC systems. Just like the ARM ecosystem, we're targeting hardware-reduced ACPI, which means you don't require this legacy of fixed, what's known as the fixed hardware interface. So basically, your chip does not need to be made to support ACPI. There are additional requirements of pulling in, like yes, you will describe your CPU and cache topology. You know, yes, if you have PCI Express that's conforming, you will expose it in the correct way and all that. And then we have some further restrictions, or I would say simplifications on supporting RISC-V systems with ACPI. With the 64-bit UEFI, again, UEFI spec has this notion of a conformance profile. This was actually added when the EBBR, or basically the simplified, you know, U-boot does UEFI spec was made, and they've defined a reduced subset of UEFI. So they introduced this notion of a conformance profile where an OS loader can basically figure out if, you know, does this system have the features I need to boot? Okay. Well, we are defining our own conformance profile, which is a superset of the requirements in the spec. It's a superset because, for example, the UEFI spec today does not mandate activating an MMU, but we want to do that for a number of reasons. Okay, so like I said, you know, this conformance profile has additional implications that you're not just compliant to what's in the UEFI spec, you're compliant to this BRS spec. Moving quickly onto the compliance test suite, the work is ongoing. This actually is basically a fork of the ARM BBR ACS. BBR is a base booting requirement. You could say it's it's kind of the model that we copied with our BRS, you know, BBR, BRS. The BBR is the ARM spec that describes the booting interface. So the BBR ACS, or the compliance, we took that, and here's the overall architecture, right? It uses the UEFI system compliance testing, which is like a test suite for UEFI. It builds on FWTS, the firmware test suite, which is a canonical project that, again, tests for ACPI and UEFI conformance, but does so within the Linux system. And then there are additional UEFI environment tests, again, to kind of tick specific boxes, you know, for BRS requirements. So that's, I gave you a link to that. You can take a look. And if you look at we've been looking at testing a QEMU implementation, the QEMU virtual machine implementation with the OVMF RISC-V virtual package UEFI implementation. And you can roughly see kind of the compliance here. So for the UEFI system testing, we're looking about passing 75%. And for the firmware compliance testing, the canonical side, that includes ACPI, it's even more, but there are more tests that need to be written. And you can see that in this specific case, you know, we targeted a QEMU configuration that had AIA and was booted with ACPI. Again, you could, so the current work and certification targets the BRS-I, the interoperable platform, which kind of makes sense because if you're targeting BRS-B, which is a very small subset of it, you probably don't care that much about compliance anyway. You're booting your own OS, you have the whole thing figured out. You're not worried about not being able to boot, you know, another OS which you don't control. So, okay, in terms of next steps, you know, the timeline for rectification is early 2024. Aaron Durbin can comment on what the actual timeline is. please join the BRS spec discussions, and please collaborate with us. There's not that many folks there. Of course, very thin on the system software engineering side. And sure, I mean, we are following kind of the same kind of industry accepted patterns, you know. We're not coming up with our own bespoke mechanisms for doing stuff, so it's not as if we don't need 100 people crew to review the document, right, and kind of make sure it's, but at the same time, you know, we really, even within the RVI community, we could use all the eyes we can get. You know, we've just found out, for example, there's a dependency on the SM bias bindings, and the DMTF spec was referencing an RVI GitHub repository, which has not a ratified spec. So something happened and the whole thing has been dead for 2 years. So we're finding gaps here and there. Please let's collaborate on the QEMU reference implementation. Please let's collaborate on the test suite. So there is work ongoing on adding, new tests to FWTS and improving the Linux ACPI support for RISC-V. So that's where we're at. I think we have 3 minutes for questions. So thanks.
So questions? Questions? Any question? Anyone? We have 3 minutes for questions or for discussions.
I mean, or
for reviewing the documentation.
Maybe I should mention that, again, the BRS, along with the server SOC, along with a, let's call it TBD security platform specs, these are the building blocks for the server platform spec, which again we're looking for, spring 24 of some availability. So the BRS is not a server firmware spec itself. The BRS is generally usable across all kinds of SBCs and servers and systems today. So we don't have some server-specific requirements in it. So the server, the server platform spec will have additional requirements, on the firmware, for example. So, yeah.
Any question? No. So, Andrew, thank you very much.
You're welcome.